Welcome to this lesson, and this will be another lesson on geometric theorems. So we're going to look at geometric theorems, and geometric theorems is an aspect of is a technical aspect of mathematics for O level that has to do with some mathematical provings in regards of geometrical shapes. In mathematics, a geometry is a branch of mathematics that deals with the properties of plane shapes and also solid shapes. So there are two keywords here. The first one is geometry and the other one is theorems. Theorems is you want to prove some properties of geometric shapes. And the shape we are going to look at in this video is triangle. Then we'll look at triangle, we'll look at polygon. Let me do triangle and polygons together. So, and let's get started. So we first need to understand, because we're talking about triangles and polygons and plane shapes, there are two things we need to understand. We need to understand size or length, or let's say we need to understand length of sides. And we need to understand theorems regarding angles. So I'll start with angles because most problems are regarding angles. In most cases, problems relating to length are easy to solve. So let's discuss on few angles. So angles are the distances or change in direction between two lines or surfaces. So you might have a line this way and you have another line this way. The distance between them in space, so that is an angle. Or you might have a line this way and you have another line this way. So the distance in them in space, so that is an angle. So when you're talking about distance in space between two lines or surfaces, so it will diverge from the same point. So because you see that they are all coming out from the same point, this is their point of divergence and this is their point of divergence. So when you have two lines coming out from the same point of divergence, so the distance between them in space is the angle. And let's look at some types of angles which you're going to come across. And usually in mathematics, angles range from 0 degree. Angle is measured in degree, and it ranges from 0 degree to 360 degrees. So let's look at the different kinds of angles that we have. The first type is the acute angle. Acute angle. So acute angle is an angle that is less than 90 degrees. So it's less than 90 degrees. So example of acute angle, we say an angle 50 degrees is acute, an angle 70 degrees is acute, an angle 45 degrees is acute. Why? Because they are all less than 90 degrees. So when you hear the word acute angle, it means an angle that is less than 90 degrees. And in mathematics, 90 degree is right angle. So if you say an angle is less than 90 degrees, it means that the angle is between 0 and 90 degrees. So this is the angle. So it's not up to 90 degrees. The entirety of this place is 90 degrees. So acute angles are always less than 90 degrees. So this is representation of an acute angle, theta. So that is a 90 degree angle. So if you say that acute angles are less than 90 degrees, then there should be a name for an angle that is exactly 90 degrees, and that is right angle. So right angles. They are angles that are exactly 90 degrees. So, and right angles are denoted by a line like this or like this, depending on the direction of the line. So, and it might also be denoted by this symbol or this symbol. So if you have a line like this and you have a symbol denoting the angle like this, so this means that this angle is right angle. Or if you have a line like this and the two lines are like this and you have a symbol like this, it means it is what? It is right angle. So right angle is always between two straight lines. One is vertical and the other one is horizontal. But if you have two lines that are not straight and you have a symbol like this, so this also means right angle. And similarly, if you have two lines that are not straight, you subtend from a point and you have a symbol like this, so it also means 90 degrees and it also means an angle of it also means right angle. So the top type of angle we look at is obtuse angle. This is U. So it's obtuse angle. So obtuse angle is between 90 degree, it's greater than 90 degree, but it's less than 180 degrees. So it's greater than 90 degrees, but it's less than 180 degrees. So which means if we have angle X such that 90 is less than X and X is less than 180 degrees. So 90 degree is less than X degree and X is less than 180 degree. Then we say that X is obtuse because X is greater than 90 but it's less than 180 degrees. And if we say an angle is greater than 90 and less than 180 degrees, so that means that the angle will look like this, because this will have been 90 degrees. This will have been 90 degrees, right? So if you do a dotted line, so this will have been 90 degrees on this point. So but this angle is greater than 90 degrees. So this is the entirety of angle. It's greater than 90 degrees, but at the same time it's less than 180 degrees, because this is 190 degree, this is another 90 degrees, so it makes an angle of 180. But this angle is less than 180. At the same time, it's greater than 90 degrees. So this is an obtuse angle. You can see that an obtuse angle is spreads out more than the vertical point of origin, whereas the right angle is between the vertical and the horizontal point of origin. So this is an obtuse angle. So and again, let me make some clean board. So the next type of angle we have is angle on a straight line. So angle on a straight line is exactly 180 degrees, or you say it's two right angles. So when you have a straight line, the angle subtended by that straight line is what? 180 degrees. 180 degrees. So this is angle on a straight line. Or you say it's two right angles. It's two right angles because this is one right angle and this is another right angle. It's two right angles because one right angle is 90 degrees. So angle on a straight line is 180 degrees. So the next kind of angle we have is reflex angle. So a reflex angle is greater than 180 degree. It's greater than 180 degree, but it's less than 360 degrees. It means that if we have angle Y such that 180 degree is less than Y and Y is less than 360 degrees, then Y is reflex. So then it means that Y is a reflex angle, and it means therefore that angle Y would be greater than 180 degrees. So let's say we have 180 degrees here. It will be greater than 180 degrees. But you know that if we have angle 180 degrees here, then another angle of 180 degrees in the opposite direction will make the total angle to be 360 degrees. So your angle X is greater than 180 degrees, but it's less than 360 degrees. So it's an angle like this that has its line like this. So this is supposed to touch this point. So this angle, the entirety of this angle subtended, is reflex angle because it's already greater than 180 degree, but at the same time it's less than 360 degree. That's because it's not up to the other 180 degree. Such angle is called a reflex angle. And the last type of angle we have is angle at a point. So the angle at a point is exactly 360 degrees, and by angle at a point, that means that 360 degrees will be what? It will be 4 right angles. So, and by angle at a point, we mean that the sum of angle subtended over a given point is 360 degrees. So we have a given point like this, and I have some angles crossing that point. So if I have angle A here, I have angle B here, I have angle C here, and here I have angle D, I can say that my angle at a point, the sum of all of the angles put together, is 360 degrees. And let's look at some basic theorems. Like I said, Theorems are like proof, mathematical evidences, how you arrive at a particular conclusion. That is what a theorem is all about. So we want to look at some basic theorems like law or conclusions in geometry. So the first one says that vertically opposite angles are equal. So, and before you can understand this theorem, you must have understood the meaning of vertically opposite angle. When we say an angle, two angles are vertically opposite each other, then you must know what that means. Now, the angle opposite each other when two lines cross is called vertically opposite angle. So they are vertically opposite because they are formed as a result of two lines crossing. So let me say this is line A, this is line B, and this is line C, this is line D. So when AB crosses CD, so then it means that the opposite angles opposite each other are vertically opposite. Like I can see, this is angle A. This angle A is opposite angle B. So we say that A and B are vertically opposite. Angle A and angle B are what? Are vertically opposite each other. So that's the meaning of vertically opposite angles. So when two lines crosses each other and the angle formed by two opposite sides is called the vertically opposite angle. So similarly, if I have an angle here and I call this angle XY, so then it means that X and Y are what? Are vertically opposite angles. And the first theorem is telling us that vertically opposite angles are equal. So what this theorem is saying is, if you have a situation like this where two lines crosses each other, then the angles that are vertically opposite, the angles that are opposite each other, are always equal. It means in this case that X is equal to Y and A is equal to B. And when you are writing statement like this in mathematics, you put your reason in brackets. So it means that if you say X is equal to Y in this case, you will say the reason is what? Vertically opposite angle. So vertically opposite angle. That is why they are equal. So this is the first theorem. Vertically opposite angles are equal. And this theorem means that if this angle is 35 degrees, this angle also must be 35 degrees. And the second theorem we are going to look at is called the theorem regarding corresponding angles. Now, two angles are said to be corresponding if they are crossed by another line. If two lines are crossed by another line, two parallel lines, so I have parallel line 1, parallel line 2, and it's crossed by another line, then this is the only case you can have the case of corresponding angle. Just like I have in the diagram, you can see that line, let me call this lines EF, GH. You can see that line EF is parallel to line GH. It's parallel because they are continuous, they are similar, and they will never meet. So EF and GH are parallel to each other, and EF and GH are being crossed by line AB. Let me call this line AB. So this is the only instance you're going to have corresponding angle, and the angle subtended by the matching point is called, or the matching corner is called, the corresponding angle. So what are the matching corners that we have? I've denoted different corners of, because this is what I have. So let me redraw that. I have two parallel lines, and I have a line cutting the two parallel lines, and I can have this angle, I can also have this angle, I can have this angle around the first line, and I can have the four corners around the second line. So which is what has been expanded into this diagram. So I have the angle ABCD along EF, and I have the angle EFGH along GH. Now if you look at A, my A here is matching my E, is similar to my E. So A and E are corresponding angles. So the corresponding angles in this case, the corresponding angles in the case of this my diagram are A and E are corresponding angles. Then C and G are also corresponding angles. C and G, which is this C and G, are corresponding angle. B and F are corresponding angles also. B and F are corresponding angle. Then D and H are also corresponding angles. And the second theorem we are just about to look at is the theorem that states that corresponding angles are equal. That's our theorem number 2. Corresponding angles are equal. Corresponding angles are equal. So it means that in this case, my A is equal to E, my C is equal to G, my B is equal to F, and my D is equal to H. So anytime you have two angles that are corresponding, then it means that those corresponding angles are equal. Let's look at alternate angles. And you first need to understand what are called alternate angles. So alternate angles also share its principle from corresponding angle, which means you have two parallel lines that is cut by a straight line. This straight line that cuts two parallel lines is called transversal. So this, when I say transversal, it means that a line that cuts two parallel lines. So in this case, this is my transversal. So alternate angles are angles that are subtended on alternate side of a transversal. So this is a transversal. This is a transversal. And the angle subtended by the alternate side, you know, when you say alternate side, this side and this side are opposite. This side and this side are opposite. But this side and this side are alternate. That's because this side is the opposite side, is the other side of this side. So you have this angle. Let me say this is angle A, this is angle B, and let's say this is angle C, while this is angle D. You can see that angles A and D are corresponding. So, and angle B and D are opposite. They are opposite each other. So these and these are opposite each other. So, and A and D are corresponding each other. So the side opposite the corresponding, the other side of the corresponding angle is the alternate side. So the angle, this is how to identify alternate angle. So by definition, we say that the angle opposite the other angle in a set of corresponding angle is called a set of corresponding angle. This should be angle. It's called the alternate angle. And in this case, we know that A and D are corresponding angle, just like I've said. But the side opposite one of the corresponding angle then is an alternate side, which means therefore that if I'm to say, then I will say that side C, angle C, this angle C is opposite one of the corresponding angle. These are two corresponding angles, A and D, but angle C is opposite angle A. So angle C is alternate to angle D, which is why I said the angle opposite the other angle of a corresponding angle. Similarly, A and D are corresponding angle. Angle B is opposite angle D. So angle B is alternate to angle A. So when you have a set of corresponding angle, then the angle that is opposite to one of them is corresponding, is alternate to the other. So this angle, angle C, is opposite to one of the two corresponding angles, then it is alternate to the other. It is alternate to this. So we say C and D are alternate angles, then A and B so are also alternate angles. So an alternate angle is opposite to one of the corresponding angles. So these are corresponding angle B and C. B and C in this case are also corresponding angle. So A is opposite one of them, then A will be alternate to B. Also D is opposite B, so D is alternate to C. So if we have an angle that is opposite to one of the corresponding angles, then that angle is alternate to the other. And the statement, the mathematical statement here is what? Alternate angles are equal. Alternate angles are equal. So which means that in this case, A is equal to angle A is equal to angle B, because A and B are alternate. Similarly, angle C is equal to angle D, because C and D are also alternate. So, and using our knowledge, our previous knowledge of mathematical statements, which we just got, vertically opposite angles are equal, alternate angles are equal, corresponding angles are equal, and also with the definition of the angles we have, then we are going to now look at some theorems. So, and to prove a theorem, like we said, is like a set of mathematical proof, like an hypothesis, which you prove with statements. So you can't just make a statement in mathematics, that statement must be mathematically proven. And to prove it, there's different items in a theorem which you need to look out for. Let me put that in a small rectangle here. The first one is you must know what to prove, and that is to prove. So you have the part that is to prove part. Then you're going to have your construction part. Do you want to add anything to the diagram? And also you're going to have your proof, which is your steps, the steps involved in the proving of your theorem. So the construction is when you say that you want to add more lines. So this allows you to add lines. You can add lines, you can add any shape just to prove your theorem, any imaginary proof, any imaginary shape, but you must know what you want to prove. So the very first theorem which we are going to prove is the theorem that says that the sum of angles of a triangle is 180 degrees. So in mathematics, someone cannot just wake up and tell us that the sum of angle in a triangle is 180 degrees. So without a proof, we ask the person, what are your proofs? And if there are proofs, we accept that statement. If there are no proof, then we are not going to accept the statement. So let's look at the three components of a theorem. The first one is to prove. What do we want to prove? Or let's look at the given. What are we given? So there is the first part, which is given. So what we are given in this case is our triangle ABC. Then our to prove is what we want to prove. So we want to prove that angle A plus angle B plus angle C is 180 degrees. So we want to prove that. So we want to prove that angle at A plus angle at B plus angle at C is equal to 180 degrees. In geometry, when you see a caveat on top of a letter, it means angle at that point. So when you see a caveat on top of A, it means angle at A, and that is A. And when you see a caveat on top of B, it means angle at B, and the same thing goes for C. Our angle at A is A, small a. Our angle at B has been given to be small b in this case, and our angle at C has been given to be small c in the diagram. So we want to prove that this is 180 degrees, and the sum of A, B, and C makes up all the angles in this triangle. So then our construction will be to extend BC. So when you see a line drawn on top of a set of letters, it means that is a line. So when you have BC and you have a line on top of it, it means side. So extend side BC and draw a parallel line to AB. So that will be our construction. So let's quickly deal with this construction so that we will not forget. So it says that extend BC. So this will be our construction. We are extending BC. Maybe we are extending BC to a point called D. Let's label that point where it stops to D. Then and draw a parallel line to AB. So we are drawing a parallel line. So this line, no, sorry, that's not straight. So and draw a parallel line to AB. That's not straight again. So we've drawn a line parallel to AB. You can see that line CE, line EC is parallel to line AB. So and we've been able to extend BC so that we can have another